Electric cars are becoming very popular these days. There are several reasons for a lot of people are continuing showing interest in these vehicles, because they create less pollution than gasoline-powered or petrol cars. So they are environmental friendly, especially in cities. Vehicles powered by fuel cells are electric cars, and fuel cells are getting a lot of attention right now. An electric car is a car powered by an electric motor, rather than a petrol engine. From the looking outside, you would probably have no idea that a car is electric. In most cases, electric cars are made by converting a gasoline-powered car, and in that case it's impossible to tell. When you often drive an electric car, the only thing that strikes you with its true nature is that it is almost silent. So today, in this video, we'll discuss about how an electric vehicle works, along with its parts and functions. Electric vehicles, also known as EVs, do not require IC engines to operate. It is powered by an electric motor, instead of a gas-powered engine. The electric motor gets energy from a controller, which regulates the amount of power, based on the driver's use of an accelerator pedal. The electric car uses energy stored in its rechargeable batteries, which are recharged by common household electricity. EVs move along our roadways without burning up fuel or producing harmful exhaust emissions, while generating less noise pollution. Electric vehicles are like an automatic car. They have a forward and reverse mode. When you place the vehicle in gear and press on the accelerator pedal, these things happen. Power is converted from the DC battery to AC for the electric motor. The accelerator pedal sends a signal to the controller, which adjusts the vehicle's speed by changing the frequency of the AC power from the inverter to the motor. The motor connects and turns the wheels through a cog. When the brakes are pressed, or the car is decelerating, the motor becomes an alternator and produces power, which is sent back to the battery. If you want to understand how an electric vehicle works, you need to be familiar with the physical elements of electric motor. And it starts with understanding the principles of its two major parts, the stator and the rotor. An electric car motor works using a physical process. This consists of using a current to create a magnetic field at the fixed part of the machine, called as the stator, whose displacement sets a rotating part, called as the rotor. The difference between the two is easy to remember: the stator is static, while the rotor rotates. In a motor, the stator uses energy to create a magnetic field that then turns the rotor. What's the difference between an engine and a motor? A motor refers to a machine that converts energy into mechanical energy, while an engine does the same thing, but specifically using thermal energy. When talking about converting thermal energy into mechanical energy, it means combustion, not electric. In other words, an engine is a type of motor. But a motor is not necessarily an engine. With electric vehicles, because the mechanical energy is created from electricity, we use the word motor to describe the device that makes the electric vehicle move. And even if you've never driven an electric car, it's still relatively simple to wrap your head around its main parts. For example, instead of a gas tank, they have batteries. Instead of an engine, they have an electric motor. And instead of a tailpipe, well, they've got no tailpipe. Simple, right? But there are few other parts that an EV owner should understand. Traction battery pack, power inverter, electric traction motor, power electronics controller, battery, charge port, DC-DC converter, charger, and transmission. Traction battery pack. The function of the battery in an electric car is as an electrical energy storage system, in the form of direct current electricity. If it gets a signal from the controller, the battery will transmit DC electrical energy to the inverter, and then used to drive the motor. The type of battery used is a rechargeable battery, arranged in such a way that it is called traction battery pack. Power inverter. The inverter functions to change the direct current on the battery into an alternating current, and then this alternating current is used by an electric motor. In addition, the inverter on an electric car also has a function to change the AC current when regenerative braking to DC current, and then used to recharge the battery. The type of inverter used in some electric car models is the bidirectional inverter category. Electric traction motor. The electric traction motors will work turning the transmission and wheels, using power from the traction battery pack. Some vehicles use motor generators that perform both the drive and regeneration functions. In general, the type of electric motor used is the brushless DC motor. A controller unit is an inverter and converter combination that recharges the battery pack of an electric vehicle during regenerative braking, which develops kinetic energy. The flow of energy from the battery is controlled using a controller unit in tandem with the converter and inverter combinations. The DC motor controller system is still used today on some electric vehicles to keep the cost down. However, with the advent of better and less expensive electronics, many of today's electric vehicles are using AC motor controller systems because of their improved motor efficiency and lighter weight. In an electric drive vehicle, the auxiliary battery provides electricity to power vehicle accessories. The charge port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary battery. Charger is a battery charging device. Chargers get electricity from outside sources, such as the utility grid or solar power plants. There are two types of electric car chargers. On-board charger. This charger is located and installed in the car. Off-board charger. This charger is not located or not installed in the car. Thermal system, cooling. This system maintains a proper operating temperature range of the engine, electric motor, power electronics, and other components. Transmission, electric. The transmission transfers mechanical power from the electric traction motor to drive the wheels. There are 4 types of electric cars are available. They are battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, and fuel cell electric vehicle. Let's find out more about these types in details, starting with battery electric vehicle. It is also called an all-electric vehicle, which ran entirely on battery and electric drivetrain. Electricity is stored in a large battery pack that is charged by plugging into the electricity grid. The battery pack, in turn, provides power to one or more electric motors to run the electric car. Examples of battery electric vehicles are Volkswagen e-Golf, Tesla Model 3, BMW i3, Chevy Bolt, Nissan Leaf, and more. Hybrid electric vehicle. These types of cars are often called standard hybrid or parallel hybrid vehicles. This type of car has both an internal combustion engine and an electric motor. In this, the internal combustion engine gets energy from the fuel, gasoline and other types of fuel, while the motor gets power from the battery. The gasoline engine and electric motor together drive the transmission, which drives the wheels. The difference between hybrid vehicles compared to battery electric vehicles is that in a hybrid the battery can only be charged by the IC engine, the speed of the wheels, or a combination of both. There is no charging port, so the battery cannot be recharged from outside of the system. Examples of hybrid vehicles are Honda Civic Hybrid, Toyota Prius Hybrid, and Toyota Camry Hybrid. Plug-in hybrid electric vehicle. It is a type of hybrid vehicle with both an IC engine and a motor. These types of electric cars provide a fuel option. These cars are powered by a conventional fuel, such as gasoline, or an alternative fuel, such as biodiesel, and a rechargeable battery pack. The battery can be charged electrically by plugging into an electrical outlet or electric vehicle charging station. Plug-in hybrid vehicles typically can run in at least two modes. All-electric mode, in which the motor and battery provide all the car's energy. Hybrid mode, in which both electricity and gasoline are employed. Some plug-in vehicles can travel more than 70 miles on electricity alone. Examples of plug-in electric vehicles are Porsche Cayenne SE Hybrid, Audi A3 e-tron, Ford C-Max Energy, and Mercedes C350e. Fuel cell electric vehicle is also known as zero-emission vehicle, are types of electric cars that employ fuel cell technology to generate the electricity required to run the vehicle. In this type of vehicles, the chemical energy of the fuel is converted directly into electric energy. Examples of fuel cell electric vehicles are Toyota Mirai, Hyundai Tucson, River Simple Raza, and Honda Clarity Fuel Cell. You can charge an electric vehicle by plugging it into a public charging station or into a home charger. But to get the best deal for home charging, it's important to get the right EV electricity tariff, so you can spend less money charging and save more on your bill. How far you can travel on a full charge depends on the vehicle. Each model has a different range, battery size, and efficiency. The perfect electric car for you will be the one you can use for your normal journeys without having to stop and charge up halfway through. An electric vehicle's range is dependent on the battery size. The higher the EV battery, more power the further you travel. Here are examples of how far some electric cars' charge will go. Volkswagen e-Golf ranges up to 125 miles. Hyundai Kona Electric ranges up to 250 miles. And Jaguar I-Pace ranges up to 292 miles. Kilowatts is a unit of power, how much energy a device needs to work. A kilowatt hour is unit of energy. It shows how much energy has been used. For example, a 100 watts light bulb uses 0.1 kilowatts each hour. An average home consumes 3,100 kilowatt hour of energy per year, while an electric car consumes an average of 2,000 kilowatt hour of energy per year. There are 3 electric vehicle charging speeds. Slow charging. It typically rated up to 3 kilowatts, often used to charge overnight or at the workplace. Charging time it takes up to 8 to 10 hours. Fast charging. It typically rated at either 7 kilowatts or 22 kilowatts. Tend to be installed in car parks, supermarkets, leisure centers and houses with off-street parking. Charging time it takes up to 3 to 4 hours. And rapid charging. It typically rated from 43 kilowatts. Only compatible with EVs that have rapid charging capability. Charging time it takes up to 30 to 60 minutes. The main advantage of an electric car is that they're easier on the environment. EVs don't even have an exhaust system, so they obviously have zero emissions. So making switch to an electric car can help contribute to cleaner air and a healthier planet. Electricity is significantly less expensive than gasoline or diesel. Installing solar panels on your home can save you even more money on powering both your residence and electric car. Electric cars do not run on oil, and therefore they do not require any oil change. Also, they don't have as many components that need to be replaced compared to gas-powered vehicles. Electric cars are known to operate smoothly and quietly, as there is no exhaust system. They are much quieter than conventional gas engines, reducing noise pollution and making the ride more comfortable. Electric motors also respond much faster than mechanical engines, providing greater torque and agility while driving. Recharging an electric vehicle is easy, and the best part is, you won't need to run to the fuel station to recharge your car. Even a common household socket can be used to charge an electric car. The main drawback of an electric car is to find a charging station. Even though you can charge an electric vehicle at home, finding a charging station can be a challenge if you're driving through the countryside or on a long-distance road trip. This will continue as demand for charging stations increases. It takes no more than 5 minutes to add gas to the fuel tank, while recharging an electric car can take some time, especially if the battery is completely depleted. It can take up to 15 to 20 hours to get a full charge on the battery pack using a normal outlet. Even the fastest charging stations will take 30 minutes to get to about 80% capacity. Driving range is limited. This can be problematic if you're planning on traveling long distances, but if you charge your car at night it should be fine for daily commutes. The upfront price of most electric cars is higher than the gas-powered vehicles.